Talc is a mineral composed of hydrated magnesium silicate with the chemical formula H2Mg3, CO3, 4 or Mg3C4010, OH, 2. In loose form, it is the widely used substance known as talcum powder. It occurs as foliated to fibrous masses, and in an exceptionally rare crystal form. It has a perfect basal cleavage, and the folia are non-elastic, although slightly flexible. It is the softest known mineral and listed as 1 on the Mohs hardness scale. It can be easily scratched by a fingernail. It is also sectile. It has a specific gravity of 2.5 Euro 2.8, a clear or dusty luster, and is translucent to opaque. Talc is not soluble in water, but it is slightly soluble in dilute mineral acids. Its color ranges from white to gray or green and it has a distinctly greasy feel. Its streak is white. Soapstone is a metamorphic rock composed predominantly of talc. Formation. Talc is a metamorphic mineral resulting from the metamorphism of magnesian minerals such as serpentine, pyroxene, amphibole, olivine, in the presence of carbon dioxide and water. This is known as talc carbonation or steatization and produces a suite of rocks known as talc carbonates. Talc is primarily formed via hydration and carbonation via the following reaction. Serpentine plus carbon dioxide or talc plus magnesite plus water, 2 mg 3C2O5, OH, 4 plus 3CO2 Mg3C4010, OH, 2 plus 3 MgCO3 plus 3 hours 2O. Talc can also be formed via a reaction between dolomite and silica, which is typical of scarnification of dolomites via silica flooding in contact metamorphic aureoles. Dolomite plus silica plus water or talc plus calcite plus carbon dioxide, 3 CaMg, CO3, 2 plus 4 CO2 plus H2O Mg3C4010, OH, 2 plus 3 CaCO3 plus 3 CO2. Talc can also be formed from magnesium chlorite and quartz and blue schist and eclogite metamorphism via the following metamorphic reaction: chlorite plus quartz kyanite plus talc plus water. In this reaction, the ratio of talc and kyanite is dependent on aluminium content, with more aluminous rocks favoring production of kyanite. This is typically associated with high-pressure, low-temperature minerals such as phyllite, garnet, glaucophane within the lower blue schist facies. Such rocks are typically white, friable, and fibrous, and are known as heat schist. Talc is a trioctahedral layered mineral. Its structure is similar to that of pyrophyllite, but with magnesium in the octahedral sites of the composite layers. Occurrence. Talc is a common metamorphic mineral in metamorphic belts which contain ultramafic rocks, such as soapstone, and within heat schist and blue schist metamorphic terranes. Prime examples of white schists include the Franciscan metamorphic belt of the western United States, the western European Alps especially in Italy, certain areas of the Musgrave Block, and some collisional erogens such as the Himalayas which stretches along Pakistan, India, Nepal and Bhutan. Talc carbonate ultramafics are typical of many areas of the Archean cratons, notably the komatiite belts of the Yilgarn Craton in Western Australia. Talc carbonate ultramafics are also known from the Lachlan Fold Belt, Eastern Australia, from Brazil, the Guiana Shield, and from the ophiolite belts of Turkey, Oman and the Middle East. Notable economic talc occurrences include the Mount Seabrook talc mine, Western Australia, formed upon a palidiformed, layered ultramafic intrusion. The France-based Luznac Group is the world's largest supplier of mine talc. Its largest talc mine at Trimouns near Luznac in southern France produces 400,000 tons of talc per year, representing 8% of world production. Uses. Talc is used in many industries such as papermaking, plastic, paint and coatings, rubber, food, electric cable, pharmaceuticals, cosmetics, ceramics, etc. A coarse grayish-green high talc rock is soapstone or steatite and has been used for stoves, sinks, electrical switchboards, crayons, soap, etc. It is often used for surfaces of lab countertops and electrical switchboards because of its resistance to heat, electricity and acids. Talc finds use as a cosmetic, as a lubricant, and as a filler in paper manufacture. Talc is used in baby powder, an astringent powder used for preventing rashes on the area covered by a diaper. It is also often used in basketball to keep a player's hands dry. Most tailor's chalk, or French chalk, is talc, as is the chalk often used for welding or metalworking. Talc is also used as food additive or in pharmaceutical products as a coolant. In medicine, talc is used as a pleurodesis agent to prevent recurrent pleural effusion or pneumothorax. In the European Union, the additive number is E553B. Talc is widely used in the ceramics industry in both bodies and glazes. In low-fire artware bodies, it imparts whiteness and increases thermal expansion to resist crazing. In stonewares, small percentages of talc are used to flux the body and therefore improve strength and vitrification. It is a source of MgO flux in high-temperature glazes. It is also employed as a matting agent in earthenware glazes and can be used to produce magnesium mats at high temperatures. ISO standard for quality, patents are pending on the use of magnesium silicate as a cement substitute. Its production requirements are less energy-intensive than ordinary Portland cement, while it absorbs far more carbon dioxide as it hardens. This results in a negative carbon footprint overall, as the cement substitute removes 0.6 tons of CO2 per ton used. This contrasts with a carbon footprint of 0.4 ton per ton of conventional cement. Talc is sometimes used as an adulterant to illegal heroin, to expand volume and weight and thereby increase its street value. With intravenous use, it may lead to talcosis, a granulomatous inflammation in the lungs. Safety: talc powder is a household item, sold globally for use in personal hygiene and cosmetics. Some suspicions have been raised about the possibility its use promotes certain types of diseases, mainly cancers of the ovaries and lungs, although this is not widely recognized as an established link. The studies reference, by subject, pulmonary issues, lung cancer, and ovarian cancer. One of these, published in 1993, was a U.S. National Toxicology Program report, which found that cosmetic-grade talc containing no asbestos-like fibers was correlated with tumor formation in rats forced to inhale talc for 6 hours a day, 5 days a week over at least 113 weeks. A 1971 paper found particles of talc embedded in 75% of the ovarian tumors studied. Recent research questions if a link does actually exist between the two. The Occupational Safety and Health Administration and National Institute for Occupational Safety and Health have set occupational exposure limits to respirable talc dusts at 2 mg/m3 over an 8-hour workday. One particular issue with commercial use of talc is its frequent co-location in underground deposits with asbestos ore, which often leads to contamination of powdered talc products with asbestos fibers. Stringent quality control since 1976 has mostly eliminated this issue, but it remains a continuing hazard requiring mitigation in the mining and processing of talc. A 2010 US FDA survey failed to find asbestos in a variety of talc-containing products. The U.S. Food and Drug Administration considers talc to be generally recognized as safe for use as an anti-caking agent in table salt in concentrations smaller than 2%. See also, silimanate, serpentinite, references. External links, mineral.galleries.com